You remember your first kiss. You remember the exact words someone said to you the day they broke your heart. You remember the smell of your childhood kitchen, the sound of a car crash you witnessed, the sting of a humiliation from third grade that still makes your face hot decades later. But here's the question that should unsettle you. What if none of those memories are the original event? What if every single time you recall something, you're not opening a file and reading it? You are rewriting it, editing it, and saving over the only copy. This isn't science fiction. This is one of the most disorienting discoveries in modern neuroscience, and it changes the way you should think about your own past. Let's start with the assumption most of us walk around with. We treat memory like a video recording. Something happens, it gets encoded, and it sits in storage until you press play. Under this model, remembering is passive. You're just retrieving. The event happened once, your brain filed it away, and every time you think about it, you're accessing the same untouched footage. This model feels intuitive. It also happens to be almost completely wrong. The story of how we found this out begins with a strange and slightly cruel-sounding experiment on rats in the early 2000s. A researcher named Karim Nader, working at New York University at the time, and later continuing this line of work at McGill University, wanted to test something specific about fear memories. He trained rats to associate a sound with a mild electric shock. Classic fear conditioning, something psychologists have done since the days of Pavlov. The rats learned to freeze when they heard the tone, because their brains had linked sound to danger. Here's where it gets interesting. Nader waited until the memory was fully formed, fully consolidated, sitting comfortably in long-term storage. Then, he played the tone again, just reactivating the memory, nothing more. And immediately afterward, he injected the rats with a protein synthesis inhibitor, a drug that blocks the brain's ability to build new proteins, which is essential for storing memories. If memory worked like a hard drive, this should have done nothing. You don't need protein synthesis to read a file that's already saved. But that's not what happened. The rats lost the fear memory. Not partially, not temporarily. The memory was gone, as if it had never been consolidated in the first place. The implication was staggering. The act of remembering the tone had made the memory unstable again. It had, in effect, pulled the file out of long-term storage and put it back into a fragile, editable state. A state neuroscientists now call reconsolidation. And if you interfere with the brain during that fragile window, the memory doesn't go back into storage properly. It can be weakened, altered, or erased. This idea didn't stay confined to rats and electric shocks. It moved into human research fairly quickly, and one of the people who pushed it furthest was Daniela Schiller, a neuroscientist at the Icahn School of Medicine at Mount Sinai. Schiller ran a now well-known study in which she used a similar fear conditioning setup in humans, but instead of drugs, she used behavioral tricks. She'd reactivate the fear memory, and then, during that reconsolidation window, present the safe version of the stimulus without the shock. It's a technique that echoes standard exposure therapy, but the timing mattered enormously. When the intervention happened inside that reconsolidation window, the fear response didn't just fade with practice. It seemed to be genuinely rewritten at the level of the original association. Do the same intervention outside the window, and the effect was far weaker. Joseph LeDoux, whose lab at NYU has spent decades mapping the neural circuitry of fear and the amygdala, has described this window as evidence that the brain treats memory less like a library and more like a living document under constant revision. Every time you pull a memory up, you are, in a very real biochemical sense, opening it for editing. Whatever happens while it's open, your current mood, new information, someone else's contradictory account of the event, the emotional context you're in right now, can bleed into the memory before it gets resaved. Now sit with that for a second, because the personal implications are enormous. That vivid memory of your first kiss? You haven't just remembered it 100 times, you have edited it 100 times. Every retelling at a dinner party, every daydream, every version of the story you've told a new partner. Each of those was a reconsolidation event, an opportunity for small distortions to creep in. The version you have now might share almost nothing structurally with the original neural pattern laid down in the moment it happened. It's not that you're lying. It's that your brain isn't built to preserve the past. It's built to keep updating a working model of the past that's useful for the present. This is where the research connects to something that should feel very familiar if you've ever followed a courtroom drama or a wrongful conviction case. Elizabeth Loftus, a cognitive psychologist at the University of California, Irvine, has spent much of her career demonstrating just how pliable eyewitness memory is. In her studies, she's shown that simply changing the wording of a question, asking whether cars smashed into each other versus hit each other, can change how fast witnesses estimate the vehicles were going, and can even implant false details, like broken glass that was never there. In some of her more famous work, she managed to implant entirely fabricated childhood memories in a meaningful percentage of participants. Memories of getting lost in a mall as a child, for instance, that never actually happened, but that participants came to describe with real emotional detail and confidence. Put Nader's rats, Schiller's fear memory rewrites, and Loftus's false memories together, and a very uncomfortable picture emerges. Memory isn't a record. It's a reconstruction, rebuilt fresh every time you access it, using whatever material, accurate or not, happens to be available in that moment. Here's the twist, though, the part that flips this from a story about fragility into a story about function. If reconsolidation were just a design flaw, evolution would likely have patched it out by now. Brains that couldn't remember reliably would be brains that got their owners killed. So why would something as important as fear memory, survival memory, be built with an editable window baked into its core mechanism? The answer researchers have converged on is that this isn't a bug. It's the entire point. A memory system that couldn't update would be a memory system trapped in the past. Literally. If reconsolidation didn't exist, a fear you learned once could never be unlearned or contextualized. Imagine associating a specific street with danger because of a single bad experience, and then being biologically incapable of updating that association even after walking down that same street safely 1,000 times. A rigid, unchangeable memory system sounds safe, but it's actually a liability. It can't adapt to a changing world. Reconsolidation is the brain's way of keeping memories relevant rather than accurate. Every time you recall something, your brain is implicitly asking, does this still apply? Is the world still like this? And it uses your current context to update the stored version accordingly. That means memory was never designed to be a historical record. It was designed to be a survival tool, constantly optimized for the present, not preserved for posterity. This reframes something that feels like a weakness. The fact that your memories drift, blur, and sometimes contradict what actually happened, as a feature that allowed your ancestors to keep pace with a changing environment instead of being shackled to outdated threat assessments. So what do you do with this practically in your actual life? This is where the reconsolidation window has started leaking out of research labs and into clinical practice, and even into how some people think about everyday habits and self-talk. Therapists working with trauma have begun explicitly using reconsolidation timing in treatment protocols. The idea is straightforward in principle. Even if it's hard in practice, you gently reactivate a distressing memory, enough to destabilize it, to put it back into that editable state. And then, while it's unstable, you introduce new, competing information or a new emotional experience that contradicts the old fear. Do this correctly, and you're not just suppressing the fear response through willpower or habituation. You may be altering the stored memory itself, weakening the original threat association at a structural level. This has shown up in modified forms of exposure therapy for phobias, in some approaches to treating PTSD, and in research on addiction, where scientists have explored reactivating drug-associated memories and then disrupting the reconsolidation process to reduce cravings. None of this is a magic fix. Human memory circuits are messier and slower to study than a rat's amygdala, and results in clinical populations are more mixed than the clean lab data from Nader or Schiller's original experiments. But the underlying principle, that memories are only vulnerable to change in specific windows after reactivation, has genuinely reshaped how some clinicians think about timing therapeutic interventions. But you don't need a clinical disorder for this to matter to you personally. Think about how often you replay an old argument, an old failure, an old embarrassing moment, turning it over and over. Under the old memory as recording model, you'd assume you were just experiencing the same static clip on repeat. Under the reconsolidation model, something more consequential is happening. Each replay is an opportunity, for better or worse, to change the memory's emotional charge. Replay it while ruminating, stewing in shame or resentment, and you may be reconsolidating it with even more emotional intensity than before, essentially rehearsing the wound deeper into your neural architecture. But replay it deliberately alongside new context, self-compassion, updated information, the recognition that you survived it, that you're safe now. And you may be doing the opposite, quietly editing the emotional weight of that memory downward each time you revisit it. This is not the same as saying you can simply think positive and rewrite trauma on command. The actual biology involves precise timing windows, specific neurochemical conditions, and doesn't always cooperate outside a lab or a trained therapist's care. But the core insight holds up under a lot of scrutiny from very different research traditions. Memory is not a vault. It's a workshop. Every visit leaves tool marks. There's something almost vertiginous about really absorbing this. It means the version of your childhood you're carrying around isn't your childhood. It's the latest draft. It means the person who hurt you years ago and the version of that event living in your head right now are connected, but they are not identical. Your head has kept revising the manuscript long after the original author stopped writing. And this brings us back to that first kiss, that heartbreak, that kitchen smell you started this video thinking about. None of those memories are lies. Exactly. But none of them are recordings either. They are living reconstructions, shaped as much by who you are today as by what actually happened back then. Every time you reached for them, you touched them, and touching them changed them, just slightly. The way handling an old photograph slowly wears down its edges. Nader's rats forgot a fear because the memory was caught mid-edit. Schiller showed human fear could be rewritten in that same fragile window. Loftus showed the same fragility could let false memories walk in the front door dressed as real ones. And LeDoux's decades of circuitry mapping gave us the biological why behind all of it. A brain built not to archive the past perfectly, but to keep negotiating with it, indefinitely. So the next time you find yourself certain, completely certain, that you remember exactly how something happened, it's worth pausing on that confidence. You're not wrong to trust your memory in the way you trust a well-used tool, but you might be wrong to trust it in the way you trust a sealed document. What you're holding isn't the original event, it's the most recent revision. And the moment you finish watching this video and start telling someone about it later, you'll be opening the file again, and quietly, invisibly, writing a new draft.